Hello folks, and welcome to another calculator video, quite a few ways away from the previous one. This one is going to focus on a calculator I acquired quite a while back before I had an unfortunate incident and actually managed to break one of my fingers. And I considered doing the video when, during the recovery period, but honestly, it would not have been the best, because what I am about to show you is a sensitive, delicate instrument, and with a big boxing glove on my hand, I would not be able to give it the gentle care and proper treatment that it deserves. So, what do I have to show you today? This is a nice little grenade case, shall we say. Very good for protecting the contents and avoiding any sort of mishaps. You can hear a distinctive noise when I'm flipping it around. The distinctive noise being no rattling whatsoever, a quality thing. And if you haven't been spoiled on the cover already, this is indeed a Curta. So I'm going to open the box up. And we're going to notice something immediately. This Curta is quite a bit bigger than the one I have shown you before. It has 11 in fact setting registers, 15 registers in the accumulator, and 8 registers in the counter or revolution register. So this one is the Type 2. It's the sequel to the original model, Curta 2 Electric Boogaloo, and it is capable of computing numbers with a lot more digits and perform divisions to a lot greater level of precision compared to the first one. Affectionately known as the Fat Boy, this one was also used by racing crews to compute lap times, fuel expenditure, and all sorts of things that racing crews need to calculate that I don't know enough about, having never been in a racing crew. Probably a fair bit of a fun job though. Whereas the Curta had a bit of an interesting marketing. It was labeled as for those who count, whereas the other machines, the original Odhners, had a bit more humble of a slogan. They just went with a machine you can count on. And as we all know, puns are the ultimate form of comedy, so I can appreciate them both, even though the Curta was absolutely marketed as more of an exclusive item for executives, businessmen on the go, and racing crews. It works much like any other rotary calculator. You set it up, put some numbers into the setting register, like that, 357. Dirty Harry's favorite number, or Dirty Harry Callahan I should say, and it's added into the accumulator, and much as before, the revolution counter, if the camera will focus, is showing the number 1. If I then take another number, such as, let's say, 39, and I turn the handle, it is added in the accumulator register, showing us 396. If I then go back to the setting register, set it to the number 4, and now try to be careful to allow you to see the ripple carry effect. The number 400 appears. We can see that in the revolution counter we have input the number 3, that is 3 revolutions of the crank. Clearing is done by pulling on the carriage top, extending it, and rotating it one full rotation to clear both the counter and the accumulator. A machine like this is also quite capable of multiplication. Let me flip this upside down to avoid the camera getting confused. Though it seems to be a lot more concerned about my teacup at the moment. It's not particularly nice of it. I think it should focus on what's important here. So multiplication is done by using the carriage and thus changing the tens factor of the thing in the input register. For instance, when it's set to the position 1, it is multiplied by 10 to the power of 0. So it's the position minus 1. So the number 1 is just a plain old 1. If I move it here, it's multiplied by 10 to the power of 1, which is 10. So the number 1 is now worth 10. In fact, looking at the multiplication up close, I turn the counter, turn the crank rather, and we will see, if the camera will focus, we will see that it says number 10 in the counter register and the 10 in the result. So 10 multiplied by 1 is 10. Straightforward. Not very useful, but let's say that we want to find out. Let's see if we want to find out if my camera will focus. There you go. And now it's not allowed to change the focus either. So let's turn it into 125. And I would like to multiply this with, let's say, 365. Let's say that you earn 125 Swedish krona per day during a year. Why not? It's not a whole lot of cash, but sometimes you make do. So I have 125 here. And I am going to set it up. So I will turn the crank 5 times for the 5 part. So it says 5 right here now. See if you see it. Yes, you do. I turn it once, and we can see that the arrow at the top is pointing to this one now. So I will turn it 6 times. So 65. We can already see in the results 125 times 65 is 8,125. But now we're going to multiply it by the 300. So 1, 2, 3. And we can see that our final result gives us 45,625. So if you made that amount of money in a day, then you would end up with an annual wage of 45,625 Swedish krona, which is not a lot if you compare it to, say, the same amount in dollars. But it is what it is. Now, let's clear this again. Division is much similar. There's the subtractive method to it. So if I put the carriage at the 8th position, we will then input a number. I like 355. I will put it into the accumulator. I will place a decimal marker, and then I will make a count. 1, 2, 3, 4, 5, 6, 7. 7 of them. And that means that there will be 7 decimals in the revolution counter. So basically it's the number of decimals here subtracted by the number of decimals in the input. So I will clear the revolution counter, and then I'm going to flip the counter reverse switch. Previously, with it in its up setting, upsetting. No, it's not particularly upsetting setting, I would say. But regardless, in this setting, any additive turn is going to be an additive count in the revolution counter, and a subtractive turn is going to be a negative count in the revolution register. By flipping this down, the number is inverted, so plus becomes minus, minus becomes plus. And I will set it to 113. So now we're going to ask ourselves, how many times does 113 multiplied by 10 to the power of 7 fit into this? And the answer is 3 times. And there is the overflow. So to correct for that, I simply turn the crank the other way. Now you might be wondering what the small, I would say buzzing-like noise is. And that is a ratchet at the very bottom of the device that is preventing me from turning the crank the incorrect direction. If I try turning it this way, the machine stops me. I do more subtractions. It's the overflow, down, add 1. On the Curta, in order to subtract, you pull the lever up, and it's going to show a little red mark, signifying that you are now doing subtractions. So, I will now continue. Overflow, add 1, step the carriage, and again, and the overflow, and there's the overflow coming up now. Add 1, turn. Going quite well so far. And there we go. It doesn't turn any further, so we can read the result. And the result is 3, and it was 1 decimal. I will move the decimal marker. So it's 3.1415929. Also known as the number pi. If you've been following my videos, you've seen this number come up quite a few times. That being said, if I show you this and tell you that, yeah, this is a fat model of Curta, of course we then have to ask ourselves the question, what does the regular one look like for comparison? So I'm going to put this down. And we're going to see the one that I had in my previous video. This box is custom made by the gentleman who sold me the Type 1 Curta. Very nice fellow. He shared quite a sad story about the fact that he had the Curta and he wanted to pass it on to his children, but they didn't want it. So instead, he took to eBay, and I was the lucky soul to win the bidding on it. I will say their loss. Now you will probably immediately see that this is rather quite a dainty little machine if you compare it to the fat one previously. The weight is, I would describe it as roughly maybe 2/3 of it. The text on the underside, it is mostly the same. The number on the bigger one is a fair bit fatter than the number of the Type 1, But both of them are made in Liechtenstein, customs union with Switzerland, by Contina Limited, and it's the system Curta Herzstark, which is the gentleman who designed the Curta in what can possibly be described as the most adverse conditions for any type of engineering design you can encounter, poor fellow. The Type 1 has 11, let's see now, contrast is a little bit wonky, has 11 digits in the accumulator and 6 ones in the revolution counter. It has a grand total of 8 input registers, whereas the Type 2 has 11. Overall, these two fishing reel looking devices are quite possibly or they are not quite possibly the smallest mechanical calculators. This is the smallest, this is the second smallest. And basically, they do what any 4-function calculator would be able to pull off today, but I would argue that they do so in style. Now, let it not be said that the electronical engineering and the computer ingenuity that goes into developing, programming digital calculator chips, let it not be said that that is not considerable. But I think I and most people would agree that there is something very, very cool about the tactile sensation and quite frankly, marvelous sounds coming out of these machines as you crunch numbers quite literally. In fact, crunching numbers is inspired largely by these calculating machines. And frankly, I am very, very happy to have both of them, because they truly are remarkable pieces of art. They're fantastic pieces of engineering and just a marvelous piece of our history, I would say. With that said, I think I will conclude the video on that note. I have to say that those of you who have been patient with me to put out another calculator video, thank you very much for that. I hope that you have enjoyed this one. It's quite difficult for me as a hobbyist to find the time to produce them, especially since these calculators they're pretty expensive. They're not super easy to come by. And right now, when I look at my collection of calculators, I find that there are not a lot of niches that I don't cover already. At some point, perhaps I will do an overview video of my collection and show the natural progression of calculators, because as far as I'm concerned, it's a very, very interesting piece of technology, and I have a nice little museum for myself, perhaps I should say, where I have from the original Odhner all the way up to the most modern electromechanical calculator produced, the Facit CA2-16, which is regrettably blocked, so I wouldn't gain much from showing it on video. And you would probably ask me, why are you showing us this lump of metal? But within the context of a greater collection, perhaps that would be an interesting thing to see. With that being said, I would like to thank you for watching and sticking with me. I hope you find it as interesting to listen to me waffle on about these machines as I find collecting and looking at them. So, thank you very much for watching. And as always, I'm open to feedback in the comments, suggestions in the comments as a matter of fact. Ideas are difficult to come by, so if you have any free ideas that you would like to pitch my way, please just put it down below. Thank you very much for watching. Have a nice morning, day, afternoon, evening, night, or other eldritch time outside of time, whenever or wherever you happen to be watching this. Thank you very much.